Hello, today's lesson is going to be graphs in practical situations. So first to begin with, we'll start with differentiating between speed time graphs, and distance time graphs. Okay, so what's the difference between them? Well, the difference is that's speed and that's distance. Actually, the difference is speed time graph represents the change in speed in a particular time interval, while distance time graph represents this change in distance from a particular point in a time interval. So, for example, if we take the speed time graph of a car moving, let's say like that, creating this graph. So here during the time interval from 0 seconds, let's say this is seconds and that's meters per second, from 0 to 4 seconds, the speed is increasing from 0 to 80 meters per second. So it's accelerating. The car is accelerating, and to find the acceleration we would use the formula A equals V minus U over T. Or we can also find the gradient, which is equivalent to the acceleration. So the gradient is equal to y2 minus y1 over x2 minus x1. So here the final velocity, which is y2, 80, and the initial velocity is 0, which is the same as y1, and x2 minus x1 is the time interval. So it's pretty much the same thing. So here in the second region, in the time interval between 4 and 10 seconds, the car is moving at a constant speed. So the speed isn't changing, it's constantly at 80 meters per second. And so we can say that the acceleration is 0. And yeah. And also in speed time graphs, you can find the distance in a particular region. So for example, we can find the distance moved by the car when it's accelerating, so that's between 0 and 4 seconds. To find the distance, we would find the area under the graph. So the distance moved while accelerating would be equal to half base, which is 4, the base of the triangle, multiplied by the height, which is 80, and that would give us the distance, which is in this case 160 meters, and that's the distance moved by the car while accelerating. And of course the same applies to the to this region here. You have to find the area under the graph, which in this case it's a rectangle, so that's 10 minus 4. Remember, this is 10, and that so this distance is 10 minus 4, which is 6, and this is 80. So to find the area we would multiply 80 and 6 to find the distance. That's all about speed time graphs. Now let's go to distance time graphs. For distance time graphs, let's say we have this graph, the same graph. So in distance time graphs, it's the change in distance from a particular point. So for example, here if we have a person walking from his home, so the distance from his home is increasing, and that implies constant speed in this part here, while here it's the distance from his home is constant, so he's not moving. So for example, if his home is right here and he is right there, the distance will be the same if he's not moving. Okay, so and to find the and to find the speed in distance time graphs, we can find the gradient of the line. So for example, the speed here, since it's not moving, is 0, and the gradient is also 0. While here, person is moving at constant speed, so if you find the gradient, which is y2 minus y1, 80 over 3. That's the speed, and that's the same thing as finding the gradient of using the formula, which is speed equals distance over time. It's the same thing, 80, which is the distance, over the time, which is 3. So that's all about speed and distance time graphs. Now we will talk about conversion graphs. So conversion graphs are pretty simple. They are graphs that we use to convert from one unit, in this case degrees Fahrenheit, to degrees Celsius. So as you can see here, we have the graph. So if we want, for example, to find the temperature in degrees Celsius of 100 Fahrenheit, so we would just draw a line from 100 until it meets the graph, and then we would go down from there and we would find the answer. So that's of course not exact, but yeah. So this is pretty much conversion graphs. They are used to convert from one unit to another in a graph. So they are also used to convert from currencies. So we would have a currency here and a currency here, and we would use it to convert from one currency to another. Okay, so now we will be talking about non-linear graphs. So non-linear graphs are graphs that are not straight lines. So for example, here we have a curve. So let's say this is a distance time graph. Oh, there is a distance time graph. So if this is a distance time graph, as you can see, the gradient, which in distance time graphs represents the speed, the gradient increases, or the steepness. So the curve becomes steeper as time passes. So increase in gradient means increase in speed. So as time passes, the speed increases, and so this means, so this graph shows that as time passes, the speed increases, and so this is an example of acceleration. So this is a non-linear distance time graph showing acceleration. So here and here, if we say this is a speed time graph, as you know, in speed time graphs the graph becomes steeper, and as you know, in speed time graphs the gradient resembles the acceleration. So if here as the time passes, the gradient increases, or the graph becomes steeper, and so the acceleration also increases, and this is an example of increasing acceleration. In this graph, let's say this is also a distance time graph. Okay, so if this is also a distance time graph, let's say the curve is like that. In this case, the gradient decreases, so the curve becomes less steep as time passes. And so in distance time graph, the gradient represents the speed, and as time passes the speed will decrease, and this is an example of deceleration in distance time graph. Here, let's say this is a speed time. If this is a speed time graph, and the curve is also curving like that, as we said, the gradient represents acceleration, so the acceleration decreases here. This is decreasing acceleration. If we want to find the speed in non-linear distance time graphs, we would of course here the speed is not constant, so the speed at one point is different from the next, and that's why we use tangents. Tangents pass through one point only, and so we can use them to find the approximate gradient at that point. So if we find the gradient at that point, of course that is equal to the speed. So that's how we find the speed in a non-linear distance time graph. Same goes for speed time graphs. We can draw a tangent at any specific point. So for example, if they ask for the acceleration at 20 seconds, so we would draw a line reaching the curve and draw a tangent that which is a line that touches one point of this curve, and so we find the gradient of this tangent, which will also be the acceleration. For the next video, I'll show you some difficult or challenging questions about graphs in practical situations.